Okay, today we're going to use the quadratic equation that we've already been working with as a function. So we're going to use things that look similar to the function of x is ax squared plus bx plus c. And we're going to look at what those make in terms of graphs. Okay, if you look at this lesson opener, if you'll remember back whenever we did linear graphs, which means it makes a straight line, you make it some type of a table, you have your x numbers, you do your function in the middle, and you have your y numbers, and you plot each of those numbers to make lines. These lines for these particular equations look like that, that, and that. Notice this plus 3 caused it to move, and this minus 3 caused it to move. The one that has nothing went right through the origin. So when we're looking at quadratic functions, it looks like this, as I already pointed out. And it's called the standard form of a quadratic function. So whenever you're graphing, we have steps. The first step is to find 5 ordered pairs that satisfy the function. We're going to do that with a table, just like you did whenever you were solving linear equations. You plot your ordered pairs on the coordinate plane, and you connect the ordered pairs with a smooth curve. We say smooth curve because instead of them looking like a straight line now, they're going to look something similar to that. Let's look at our first example. Our function is x squared. So if we fill in numbers for x and we solve it, then we're going to have our function number. And when we graph these, we have another function here that's 3 times our x squared. So let's see how that changes things. Okay, now because that second function is each point is 3 times higher than the corresponding original point, you can see that we have 2 different lines. This one is our original one, just the x squared, and this one is our one that's 3 times the x squared. And notice how it's more narrow. These are both called parabolas. And whenever you multiply, it makes it more narrow or steep, however you want to look at it. The slope is steeper. Okay, let's look at these 2 functions. We first make a table. And we look at the other function and how that is, we're going to look at how that changes things. So notice this first one is negative and this second one is just a half here. So let's see how this changes things whenever we actually look at them. When we think about the parabola, the vertex is the part where it actually curves. This would be our vertex. In a typical x squared, it's going to look like that. Everything's going to be exactly the same on each side. Now, this line here in the center is your fold line, which is the line of symmetry, which divides the halves that look exactly the same. Now, whenever we change things around, if a is greater than 0, so if this number is a positive number, then the graph is going to open upward like this. If it's a negative number, it's going to open downward like that. When we look at that number also, if its absolute value is greater than 1, so whether it's negative or positive, if it's greater than 1, then it's going to be more steep, whereas if it's less than negative 1, it's going to be more flat or wider. Okay, so let's graph some parabolas and compare them. So we have our x squared and we have x squared plus 2. Let's see how that changes. Notice that each of these numbers is 2 more than the original numbers of the original equation. So when we graph those, this is our original one, our vertex just moves up 2 spots and everything else is 2 higher, 2 higher, 2 higher, 2 higher. Each point is 2 spots higher. Let's look at this next example. So we have this function of 3 times x squared, and we have 3x squared minus 4. We've already looked at what 3x squared looks like. Let's look at how things change when we do minus 4. Our original vertex, this was our original one right here. Our original vertex was at 0. And when we do a minus 4, it makes everything move down 4. Each of the points move down 4 spots. Okay, so let's look at what happens whenever we add that constant. Let's just think about that. If c is positive, then it makes it move up, and if c is negative, it makes it move down. So if you have whatever you have here, if you have a plus or a minus here, the vertex, everything stays, all the points move up or down. So go ahead and get started on your homework and refer to your book if you have any questions.